My name is Katja Hoffmann. I'm a principal researcher at Microsoft Research in Cambridge, where I lead a group that focuses on game intelligence. I got into this field, quite a long time ago when we didn't call it AI as much. We were calling this machine learning. And I started my research career looking at how search engines could learn directly from their users. When I wanted to do more fundamental research in settings where we could explore, for example, more complex behaviors, this kind of search for the space where we could explore this brought me in the direction of video games, and especially Minecraft being so open-ended turned out to be a fantastic platform for driving this research, because we could set up a huge variety of tasks which would allow us to really test out the boundaries. Rather than working with applications that are already there, we could imagine what these applications could look like in the future.
I'm William Gus, and I'm a research scientist at OpenAI and a PhD student at Carnegie Mellon studying reinforcement learning. So I grew up in Salt Lake City, Utah, and I started getting into gaming because of my brother. He showed me Minecraft early on. I was really excited about it. In that process, I was kind of always yearning for the world to be more reactive. Having an NPC that actually would play with me like another human would, or would actually interact with us in that way. I wanted to do more with the game, and so I started to learn how to program. The story from that is just I realized programming is this wonderful thing in the same way that Minecraft was. I can build whatever I want. It's the same kind of joy. And so I actually did some research, and there was this algorithm for sort of codifying some artificial neural networks and having that interface with whatever sort of programming that you're already doing. And it was really crazy to me because all the programs I'd written up to that point were just I'm making a calculator, or I'm making some sort of application, and you know exactly what's going to happen. But when I codified this neural network and I gave it data and it started learning, it was alive. It's like imagining your Lego set coming to life. And that's the big question. It's how far can you push these techniques, and how close can you get to societies and Minecraft, all of these things that you would expect humans to do, but having a neural network do it itself. I think once you are behaving like humans in all these settings, you're already able to ask questions about intelligence that you weren't able to ask before. Then I can say something about, well, okay, I have an agent that's very close to a human, and when humans or these agents are placed in large-scale environments like this, they behave like this, I can make judgments about human behavior that I couldn't before. I think that's the Wild West. That's a new type of research. So having that sort of manifest is quite interesting, I think, in terms of learning about ourselves.
So we started Project Malmo about 4 or 5 years ago, and our goal was really to develop a general purpose experimentation platform, especially for AI researchers and students and other enthusiasts, so they could create their own experiments easily. And we envisioned this as a platform that would grow with our understanding of what AI technology can do. For example, we started from relatively simple examples of teaching agents to navigate small rooms, avoiding lava, and then over time, these tasks have become more and more complex. Reinforcement learning is one of a wide range of artificial intelligence techniques. It's a type of machine learning where we think of systems or agents that are autonomous in a way, in the sense that they take actions in their environment and then they learn from the consequences of these actions. For a very long time, there was this notion that reinforcement learning agents would purely learn a single given task. So for example, it wouldn't necessarily understand that lava is bad. It would just remember that, oh, I stepped on this square in this situation and it was bad, and so I shouldn't do that again. Now, this generality is really the question of what structure or maybe what training approaches do we need to put in place so that agents learn to understand the world in a more general, more meaningful way, so that they can learn that lava is bad and that there maybe are types of material that it cannot step on. And then when it's put in a new environment, and it encounters, for example, water, that it might be using some information about what happens with lava. So generalizability is a really important challenge that needs to be addressed before many new real-world applications can be enabled. If we just take this example of household robotics, let's say you want a robot that is able to clean up in your home. Well, it probably wasn't trained on your homes. It needs to be able to understand what a carpet is, what a floor is, what the typical items in a kitchen are, and what you do with them. And that is the kind of general knowledge that we want these agents to learn to build up in the long term.
So Malmo is a research platform, and ours is an actual sort of direct research project, which is like, how do we build AGI using human data in Minecraft? So we built this challenge called the Mineral Challenge. And so we partnered with Microsoft, and the whole sort of mineral competition in itself is basically, how do we show that using reinforcement learning isn't the best way to do this?
So we met up for coffee, and he was basically suggesting a version of that competition. He was sketching out what it would mean to collect a large amount of data so that people could try and see how to best use human demonstrations as a starting point for training AI agents to do these much more complex tasks than what we had tried so far. And in particular, we settled on the idea of having agents learn how to mine for a diamond.
And effectively, what we did is we created this data set of like a simple task to humans, which is like obtaining a diamond. And then we said, okay, AI researchers, instead of trying to, solve this task with reinforcement learning, the Mineral Challenge said, okay, take this data, train an agent to solve this task, but you only have 4 days to do it and 1 computer to do it on. It was sort of this really cool moment in sort of RL competitions, because for the first time we were seeing the top techniques being so drastically different and so diverse, not only in the algorithms that people were coming up with, but also the behaviors of the agents that people were developing. So it was a completely like lack of hard coding. It was a really cool result, I think.
And it was really, really humbling to see end of last year, the exciting progress that all the participating teams had made towards actually developing new RL algorithms that could address this challenge.
And actually getting very, very close to attaining a diamond, which is just like something we didn't expect at all. And I think where we see breakthroughs in science is when we have people coming from left field, out of nowhere, and actually sort of implementing ideas and trying stuff that you really wouldn't expect. Microsoft generously sort of sponsored a lot of the compute, and so we saw people from like universities that we had never seen compete in AI competitions before competing, because people had access.
So with AI in general, I don't believe that technology is either good or bad. I think that people use technology for different purposes, some better than others. And as many more people come to understand the underlying technology, they can for themselves have a better understanding of what the opportunities are, what the limitations, and maybe what the risks are. So I think there is a really important role for education to kind of get as wide a set of people as possible contributing to that conversation of what kinds of AI techniques we want and what kinds of applications we want in our lives. One of the latest developments around Project Malmo is a collaboration that we have started with Azure Machine Learning. As I mentioned, I believe it's really valuable for many, many people to understand the potential, the uses, and also the limitations of new AI technologies, so that everyone can figure out what kinds of applications they might want and maybe how AI and other related technologies might help in their daily lives. Now, in this collaboration with Azure ML, we have built samples that showcase how Azure Machine Learning can be used to train reinforcement learning agents. And one of the examples we have recently released is using Project Malmo. So you can go to the website that's shown in the description of this video, and you can try this out for yourself today and train your first reinforcement learning agent.